Okay, now I'm ready. You will have time to finish those definitions in a second. So, let's get started, okay? This test tomorrow is multiple choice, okay? And it's going to cover lab safety. It's going to cover properties of matter and changes of matter. It's also going to talk a lot about solids, liquids, and gases and what those particles look like and do and things like that, okay? So, first thing we're going to talk about is lab safety. What's the number one rule in lab safety?
No horseplay.
Nope.
No eating or drinking.
Nope. What are you going to do if anything goes wrong?
Tell
Tell your teacher. Okay, so the number one rule in lab safety is tell your teacher. Okay, I might want to add that if you have this test review completely filled out and you turn it in tomorrow, you get extra points on your test. Okay, so stay with me today and you're going to have a really easy time getting those extra points. Alright, make sure you remember the safety rules we talked about in class. Somebody tell me, what should you wear in the lab?
Closed-toed shoes.
Closed-toed shoes.
Goggles.
I can't write that fast.
I can. Gloves. Ponytail. No jewelry. No baggy clothes.
What else you got for me, John?
No baggy clothes.
I got that up there.
Oh, ponytail.
Got it.
Apron.
Gloves.
Apron. We don't always wear gloves, so I'm not going to put that up there.
Goggles?
Got it.
You do have that.
There's not jewelry on there.
There we
Oh
go.
yeah, I put jewelry down. I thought I said that.
He did say it.
You did, but she didn't write it.
Oops.
Yeah, John, I didn't like how you said it, so I chose not to write it.
Oh, sorry.
I'm just kidding. Okay, so things that we need to take care of in the lab as far as what we wear. There's no closed-toed shoes, so you never want to wear sandals in the lab. You don't want to spill anything on your freshly pedicured toes. Safety goggles, so that you don't get anything splashed in your eye or a glass goes in your eye. You know, that would be really terrifying. If you have long hair, we want to have it tied back in a ponytail of some sort. No baggy clothing, so that your clothes don't catch on fire. You're going to want to wear an apron or a lab coat of some sort to protect yourself and your clothing. And then no dangling jewelry. We don't want anything to get inside of a chemical or to catch on fire, anything like that. Okay? A couple of other rules that we want to keep in mind is no horseplay. And then do not taste or smell chemicals.
You gotta walk it.
Yeah, you want to waft. Okay? So no matter what, tell your teacher, and then also follow these other safety rules. Okay? Mainly no horseplay. That kind of encompasses a lot of different things. And then make sure we're wearing or not wearing these things in the lab. Alright, what to do if? What are you going to do if you spill a lot of chemicals on your body?
Go to the
Don't
shower.
panic.
Tell the teacher and then what?
Get naked.
Emergency shower. Okay? Emergency shower. My marker is really fat, so I can't fit everything on my line. What are you going to do if a chemical gets in your eye?
Emergency shower.
The eye wash station after you tell your teacher. What about if a glass breaker beaks on the floor? I love when stuff beaks.
Tell your teacher.
Tell your teacher. Yes. Okay, I do not want you guys picking up beacon glass. Get it? Broken? That's the new word now.
What did you try to do? Combine beaker and broken?
Something. Yeah. Okay? So, moving on after lab safety, we have types of matter. Okay, I want you to use these definitions from this paper. Okay, element, substance with atoms that are all alike. Compound, substances in which the atoms of two or more elements are combined in a fixed proportion. Okay, you should have picked up this paper when you walked in.
Oh.
Write those definitions right here for element and compound, and then I'm going to add some stuff to them. Okay, for element, we have some examples here. Hydrogen, iron, and carbon. After your definition, I also want you to add that they cannot be broken down. Cannot be broken down. Add that after your definition. For compound, we're going to add some stuff. Examples, we have salt, carbon dioxide, and water. And then in addition to that definition that you wrote down, I want you to write that they are chemically combined. And can be broken down using a chemical reaction. Okay, so make sure that gets added to the end of your compound definition. Okay, just some different terminology there. Elements, they cannot be broken down. Compounds can be broken down if you use a chemical reaction to break them down. On that next page, if you're ready for that next page, you're going to write the definition of mixture down from that second paper. Okay, so on that second page, you're going to write the definition of mixture from this paper right here. Matter composed of two or more substances that can be separated by physical means. Okay? I also want you to add that mixtures are physically combined. And easily separated. Okay, add that after your definition. Physically combined and easily separated. Okay, within mixtures, we have two types. Okay, we have homogeneous mixtures, and we know that homogeneous mixtures are going to look the same. Homogeneous mixtures look the same. A few examples we have is air, like the air we breathe. Coffee, milk, salt water, and brass. Okay, so those are all mixtures to where you can't see the different parts. It looks the same throughout. So those are homogeneous mixtures. Homogeneous mixtures are also called solutions. Okay, second type of mixtures are heterogeneous, and they look different throughout. Some of those examples are granite. What?
Salad.
A salad.
Pizza.
Pizza.
Spaghetti.
Yes, spaghetti. Marble is another one. We can fit spaghetti on there.
Lasagna.
You hungry for some pasta or what?
No, I don't like pasta.
What?
I like fettuccine.
Okay, so you can see the different parts of these mixtures. You can see the different parts that make them up. So they are heterogeneous. Okay, and then another note. Okay, this is not a mixture. It's just something to always remember. Type of matter that cannot be broken down, we said earlier, was an element. Alright, so that is types of matter. Okay, keep in mind those definitions on that second sheet I gave you. That's going to be a good thing to study as well. The next thing we need to talk about is properties of matter. Okay, so properties are going to describe. Properties describe something. Physical properties.
Hard.
Characteristics. That can be observed. Without changing the substance. Characteristics that can be observed without changing the substance. Okay, there are two types of physical properties. The first type is going to be intensive. Okay, this is the first type of physical properties. Intensive, they will stay the same. No matter how big or small the substance is. Okay, so some common examples of intensive physical properties that you're going to need to know are density, color, shape, boiling point, and taste. Okay, so all of those are intensive physical properties. Remember, anything that's intensive is also physical. Let's talk about density a little bit. Okay, so density is intensive because if I have a bottle of water, the density of water is still 1 gram per cubic centimeter. Okay, if I have an ocean full of water, the density of water is still 1. Okay, so even if I have a small amount of water or a huge ocean full of water, density doesn't change. It's always 1. Okay, so that means it's intensive because it doesn't change. All right. More specifically with density, how do you know if something will float? We talked about this earlier in the warm-up. Density is less than 1. Okay, if the density is less than 1, then it is going to float. Density less than 1 means that it's going to float. All right, our second type of physical property is extensive. So extensive is going to change changes depending on how big or small the substance is. Changes depending on how big or small the substance is. There are only 3 of these ever. Okay? Only 3 are mass, volume, and length. There's only 3 ever. Those are the only 3 there's ever going to be for extensive properties. Okay? It'll only be those 3 that are extensive. I'm going to say that one more time. Okay, I'm going to show you guys how I remember which 3 are extensive. Okay? So if I have EXT right here, okay, let me get a different color. If you flip the E on its side, it looks like an M for mass. The top of the X is a V for volume. And that T I can change into an L for length. Okay, so that's how I remember that extensive is mass, volume, and length. Alright, that's just another way to remember it. Or you just get it in your mind. Extensive is mass, volume, length. Mass, volume, length. Alright, so that's it for my physical properties. Next, I have my chemical properties. And this is going to be any property that can be seen during or after a reaction. Okay, so one of our examples is flammability, and I don't know if something's flammable until it catches on fire. Okay, so that's why it's a chemical property, because I can't see it until it happens. All right, so flammability is an example. If it's reactive or not, in general, is a chemical property, the reactivity of something. And then corrosiveness. So corrosiveness is if something can like eat your skin or eat through metal or something like that. Okay, those are just 3 examples of a chemical property. You don't know it does these things until it's already done it. That's how you know if a chemical change is happening, not a property. All right, let's get through this last page. Now we have changes in matter. Okay? Physical changes can usually be reversed. And they happen when a substance is changed but keeps its composition. Another word I like to use for composition is identity. That looks like crap. Alright, examples. Cutting something. It doesn't change what it is, it just makes it shorter. Tearing. And phase changes. Okay, this is a big one. If I go from ice to liquid, it's still water. It just changed phases. So phase changes are always going to be physical. Phase and physical start with the same two letters. So keep those together. Phase changes are physical changes. Yes. Yes, I'm sorry. Chemical changes. When a substance changes and creates a new substance with new properties. Okay, so a chemical change happens when something new happens, or you can't get it back to its original state. Okay, so if you are making scrambled eggs, can you change those eggs back to raw?
No.
No, so that's probably a chemical change. Okay, common examples: rusting. That's the oxygen reacting with the silver or iron of a metal. Burning. So if you burn wood, you can't get that wood back. Cooking is also an example. Okay? Okay, the last section of the test is going to be states of matter. What are the states of matter?
Solid, liquid, and gas.
Solid, liquid, and gas. Those are our three states of matter: solid, liquid, gas. Somebody tell me, what's the particles of a solid going to look like?
Packed.
They're gonna be packed?
neatly.
And stacked neatly. Okay, so the easiest way to do this is to make a square. Okay, they're really, really neat, and they're really, really close together. Liquid are still going to be close together, but they're going to be more random. Okay, they're not going to be as neat. And then gases are all over the place, not touching. All right, what state of matter has the most kinetic energy?
Gas.
Gas, okay, because they move around like those bouncy balls going down a staircase. Okay, what state of matter has the highest force of attraction between particles? Solid. And how does temperature affect how particles move?
It slows down.
So if the temperature goes up, then speed goes up. If the temperature is down, like cold, then speed will go down. Okay, so hotter things move faster than colder things. All right, if you guys go and look on Canvas and you click on Unit 1 and 2 Test Review, there's a bunch of links there. Those are things that I recommend studying. Okay? I also recommend studying this phase change diagram. Okay? We all filled one out in class. It's also on Canvas. Okay? Our test is going to be tomorrow. So make sure you're ready for it. If you filled out this entire test review, take it home and study it. And if you turn it in tomorrow, you get extra points on your test. Only if it's filled out.